Question is question number 14, page number 43. Yeah? So the question is, due to some force F1, a body oscillates with a period of 4 by 5 seconds and due to other force F2, it oscillates with a period of 3 by 5 seconds. If both forces act simultaneously in same direction, then new period is. So you can say this like this. There is a body which is oscillating. So let us say body is a simple pendulum. When you apply a force F1 in this direction, so as F proportional to, if you are displaces through distance x, restoring force acts in this direction. So if restoring force is directly proportional to minus x, you can also say F is equal to minus kx. The magnitude, if you consider, is equal to kx, but k is m omega square x. So F is equal to this. So F is equal to, we know that F is equal to m omega square x. But here, under F1 force, it is oscillating with a time period of t1. Here, omega can be represented with for 2 pi by t whole square, and in terms of time period you can express. Let us keep it now in terms of omega only, then you can convert it next afterwards. So F2 is equal to m omega 2 square x. And F3, that is, if F1 force acts, it is oscillating with a period of t1, which is involving in this. F2, with F2, when F2 force is there, it is oscillating with the period of t2, which is involving in this. But if these two forces combine in same direction, if you say new force F3 is acting, which is equal to F1 plus F2, then it is oscillating with a new period. What is that period is the question. So you can express it as equal to m omega 3 square x. So that means here, if you substitute this in terms this omega forms, after cancelling, simplifying this, cancelling and simplifying this, you can write omega 3 square equal to omega 1 square plus omega 2 square. Omega can be now expressed as 2 pi by t whole square. It gives you 4 pi square by t3 square is equal to 4 pi square by t1 square plus 4 pi square by t2 square. 4 pi can cancel out, then you'll get this relation. So here t1 t2 is given, here asked to find t3. So t1 is, because t1 is equal to 4 by 5 seconds and t2 is 3 by 5 seconds. What is t3 is the question, right? So if you substitute here, then simplifying, so actually here 5 square to 25, we take it out because both are common here. In both the terms it is common. You write it as 25 into 1 by 16 plus 1 by 9, and simplifying this further, 9 plus 16 is 25 by 9 is 16 into 9. So that is 1 by t3 square. T3 square is, it will get reciprocal of it. 16 into 9 is 144. 25 into 25 is 160. 625. So from this you can say T3 is equal to square root of this gives you 12 by 25. That is 0.48. That is the period when you apply these forces together. When individual forces are acting, the periods are this. When both the forces are acting, when the both forces are acting simultaneously in the same direction, the new period will be this much. Okay, so you can also say here decimal, in decimals also, this will be approximately 4 by 5 means 1 by 5 is 0.2, so 0.8, this is 0.6. 3 into 0.2 is 0.6, 0.8, 0.6 seconds. Here it will reduces. That's how we can take it. Okay, effective time period. Right. So question number 9, page number 47, or you can say it is level 3. Level 3, yeah?
Yes, sir.
Level 3, question number 9. Come this. So the question is, the xt graph of a particle undergoing simple harmonic motion is shown in figure. Acceleration of the particle at equal to 4 by 3 seconds is. So xt graph is given as shown in figure. The figure is this. This is position. Xt graph means position time graph. Position is taken on y-axis, and this is in centimeters. This is given in centimeters. And t, time is taken in x-axis. T is taken in seconds. So that it is given that it is this one. It is a sine curve. It is a sine curve. Provided it is 0, it is 4, and this is 8. This is given as 12. This is 1 plus 1. This is minus 1. Amplitudes, right? Varying between plus 1 and minus 1. So this is displacement time curve. Is the position is varying with the time as by using the can say position is varying with the time in this way. So that means it is increasing from 0 to maximum value of this, then again decreasing to 0, then again varying accordingly. So this can be expressed mathematically as what do you call it? This represents a simple harmonic function. So we can say that x you can express it as x is equal to a sin omega t, because it is varying in sinusoidal form, where amplitude is 1 plus or minus 1 is 1. So you can take it as in place of a, you can take it as, because a is equal to 1, you can take here 1, x is equal to a sin omega t is this time omega t. But here omega in terms of time period you can write it as sin 2 pi by t into t, because omega is 2 pi by t, right? Because omega is equal to 2 pi by t. You can take this capital T time period into t. The instantaneous time is this. So this here from this graph you can understand that time period is nothing but time taken to complete one cycle. This is called one cycle. Time taken to complete one cycle is nothing but 8 seconds. This is in seconds. So capital T can be taken from the graph. Capital T is 8 seconds. From this T is equal to 8 seconds. So if you substitute this here, then and simplifying, 2 4 it can cancel out, right? So you can write it as pi by 4 into t. So sin pi by 4 into t is x. X is equal to x is equal to sin pi by 4 into t. But what is the question? At time t equal to 4 by 3 seconds, what is acceleration? So this displacement, from displacement time graph, you can get displacement, what do you call it, instantaneous displacement is a function of time. So from this, if you want acceleration, you have to double differentiate your position, or you can say if you differentiate this with respect to time, you will get velocity. Then if you are differentiating that with respect to time, you will get acceleration. So first velocity is dx by dt. Velocity is dx by dt. That is nothing but if you say this is sin omega t, sin omega t differentiation is cos omega t into omega. This is omega. Omega part is pi by 4. So that if you take it out, they can write it as pi by 4 into cos of pi by 4 into t. Then again, if you differentiate this velocity with time, with respect to time, you will get acceleration, that is equal to dv by dt equal to d square x by dt square is equal to, if you differentiate cos omega t, you will get minus sin omega t into omega. So minus sin pi by 4 into t into pi by 4, again already 1 pi by 4 is there. So minus pi square, pi by 4 into pi by 4 is pi square by 16 into sin pi by 4 into t. And this is acceleration in terms of time, we call it as instantaneous acceleration. But you're asked to find at time t equal to 4 by 3 seconds, what is acceleration? So that means if you substitute the time t equal to 4 by 3 seconds here, then we'll get a equal to minus pi square by 16 into sin pi by 4 into 4 by 3 plus of t, and we substitute for 4 by 3. 4 cancel, we'll get pi by 3. Pi by 3 is 60 degrees, and 60 is root 3 by 2. So minus pi square by 16 into root 3 by 2. So root 3 pi square by 16 is 32. So you can write it as acceleration A is equal to minus root 3 pi square by 32. The units in the graph, it is mentioned that x is in centimeters. So unit of the final acceleration should be in centimeter per second square. If that is in meter, then it should be meter per second square. That also should be careful. Okay. Yes, that's it.